Hello and welcome to Humanoid Robotic Insights. My name is Jack Hallewell and today I'm incredibly excited to be joined by Nicolas Giraudo, the Chief Commercial Officer at Alva Industries. And today we're going to be talking about all things motors for humanoids. Thanks very much for joining me, Nico.
Thank you, Jack. Thank you for having me.
Could you please start by providing a background to yourself and Alva Industries?
Well, as you say, my name is Nicolas Giraudo. I'm the Chief Commercial Officer of Alva. I joined almost a year ago. And I joined Alva to be part of a change of strategy where we were doing mostly propulsion systems. And now we are expanding, going into torque motors and more precision-driven markets. Alva is a motor manufacturer, and we do make and design our own motors with our unique technology called FiberPrinting, and the company is based in Norway.
Thank you. And where are frameless motors typically used within humanoids?
So, humanoids have a lot of actuators. Mostly they are using frameless motors or torque motors, as we can call them too, in joints, big joints. Why? Because those big joints will require compactness and also will require a lot of torque, right? Because you're moving your shoulder, the knees, the hips of the humanoid. So those are in those joints is where frameless motors can be used in combination with a gearbox or as a direct drive.
Perfect. And what are some of the main problems that humanoid manufacturers face when they're designing their mechatronics?
Yeah, this is an excellent question. There might be many different challenges. As you know, this market is supposed to go big, and every single person of us should have in the future a humanoid in our houses, which leads us to the number one challenge I think they face, which is cost related. But if we talk about in terms of the technical challenges they face is, of course, compactness, trying to make actuators as compact as possible, and also the torque density or the torque that you require on the motor to be able to achieve those torques on the actuators in general. Those are the main challenges, which leads to mechanical integration. Try to make everything compact, putting your encoder, putting your gearbox, putting your brakes is all part of the challenge in general. And another challenge that we hear, like now talking in particular on the motors, is the flexibility. Every single humanoid manufacturer out there is trying to make a different robot that has a differentiation, and that leads into having to look for specifications on motors that are different, and having the limitation of having to choose something that is available is difficult. So having the flexibility on that design is key for many humanoid manufacturers.
And so based on these challenges, what are some of the main motor attributes that engineers should look for when selecting a motor?
When we are analyzing a data sheet of torque motors, we typically gonna see different specifications that are daunting sometimes because we have the diameters, the lengths, the torques, the carrying consumption, and so on. We always recommend to focus on the constants, and the constants could be the torque constant or the motor constant. The torque constant is telling you basically how much torque are you gonna get out of the motor respect to the current that you're applying, and the motor constant is telling you how effectively you're transforming the electrical energy into mechanical energy. So the motor constant is actually better in terms of knowing how much are we getting in the torque from the motor based on the energy we're putting it. And if we take those constants and divide them through the mass or the volume, we will get gravimetric or volumetric constants that are very important to compare pairs to pairs, apples to apples in the motors, right? So that is the things you have to consider in terms of specifications, in terms of technical stuff. Now, I mentioned also cost. One of the things that engineers definitely need to consider, knowing that this is going to be a big volume and a big market, is to select motors that are able to be produced in an automated way. If the motor that you're selecting is made manually, or the windings of that motor are made manually, or any manual process is involved in the manufacturing of that motor, that's going to be tricky, right? Because you're going to have to go in volume and reduce the cost as much as you can. So the selection of the technology should also be based on how the motor is manufactured.
Perfect. And so could you please now tell me about the products that Alva offer to this market and how you help the engineers with their designs?
So we do motors that are made by our unique and proprietary fiber printing, right? So we do our mats, and these mats we can do in different ways. We are very flexible and making it shorter, longer, thinner, and that is going to become our standard, right? In the typical case, we also can do outrunners, but if we talk about the inrunners, this is going to be our starter that we are going to put into a mold, and that's going to become the starter of the motor. And then if you see, our motors are extremely thin, right? So if we talk about mechanical integration, trying to be compact, that's what you're looking for. And then the slotless technology is not only important for being compact and very thin. If we compare it with a rotor, this is how the motor looks like. It's not only compact and light, but also allows you to be very flexible in terms of how we are building this motor. And our technology is comparable in terms of performance with the slotted design, which is the main aspect of the fiber printing technology. If we think about humanoids, normally you will compare slotted and slotless and think that a slotless, it has less torque. But in fiber printed slotless motors, it's not true. Our performance is comparable, but being lighter and thinner.
And you touched on it briefly just in your previous answer, but could you now please go into a bit more detail about your fiber printing technology?
Sure. So this is the brain baby of our founder, who came up with this technology, trying to find ways of making a motor that has more copper and there's comparable performance with a slotted design. So the intention or the aim for this was to make a technology for making slotless motors that is scalable and automated, and this is the result of that. In fiber printing, even though there's a weaving technology, and we actually don't print per se the mats, but that's basically the way we do our windings. This gives us a lot of flexibility to go from an idea of specifications into a design in a very easy way.
Thank you. And so how does a typical development project look like at Alva? For example, would a manufacturer need to purchase, thousands of motors?
No, you don't need to buy 1,000 motors. It all starts with a design study. So we typically discuss with our customers first what are the specifications they are looking to get, and not the set of specifications that they are getting from their motor supplier, but rather what they are looking for, what they are trying to do. And then based on that, we can do a design study. And this design study is very easily and quickly done, the fastest I ever seen in my career. That is coming from a simulation, a software that we designed and made, where it allows us to very predictable say how the specifications of our motors will be. And then we discuss that with our customers to see if those specifications are okay. And then we are pretty flexible on changing things because this technology allows us to do a lot of different things on the motor. And then after the specifications have been set, it's about 16 weeks more or less from the specifications up to prototype delivery right now. We want to get that down to 12 weeks during 2025. And we are also analyzing possibilities to do quick customizations to be even faster than that during 2025.
And what if I'm not ready to invest in a full development and I just want to test the motors?
We have launched this year a series of motors called Slim Torque that allows you to do a quick testing. So we do have this standard portfolio of products, and recently we made a product selector where you can go and check different specifications and see which of our standard motors will adapt best to your set of specifications you want to test. That's the approach that will require still that you take the frameless motor and house it somehow, or have bearings, or have a small bench device so you can test the motors. If you don't want to do that, we also have made this year housed versions of our motors that are not intended to be commercialized in a volume or in volume for our customers, but rather they serve as a quick testing motor that can be plugged and play on the drive that you're using. So there are those two ways. One is a little bit less integrated, and one very integrated version of our models or our motors or our technology, so you can quickly get to test and see that the wonders of fiber printing are true.
Thank you. And finally, how can humanoid manufacturers learn more about Alva?
Great. Well, I invite all humanoids manufacturers to reach out to us at sales@alvaindustries.com, or to go to our website, alvaindustries.com, and check out our product selector or series of standard products, or reach out to discuss a potential customized motor for your project.
Nico, it's been a pleasure. Thank you very much for joining me.
Yeah, thank you, Jack, for having me again. It's been a pleasure for me too.